so let's do some examples of using the table. We're going to start with probably the most obvious way, using a z-score to figure out a proportion. So what I want to know is what proportion of the normal distribution corresponds to a z-score of 1 or higher. What proportion of a normal distribution, it always has to be a normal distribution because it's a table for normal distributions. What proportion of a normal distribution exists above a z of 1, a z of 1.00, so it's positive, and it's one standard deviation in. Now again, we don't need the mean line and all the other lines. And the question asks for what's above it or what's below it. I want to know what proportion of the normal distribution exists above a z of 1. So, am I looking for the proportion of scores in the body or in the tail? And the answer is the tail, the one we shaded. It's such a simple thing, but believe me, if you don't do it sooner or later, you're absolutely going to mess it up. You're going to absolutely stub your toe because it's a simple thing to screw up. So, we want to know the proportion of scores that are in the tail. So, we need to get into our Appendix B. Again, keep that open this whole chapter. You're going to need it all the time. And you're going to go down the Z column until you find a Z of 1. So go through your columns and scan down the Z's until you find a Z of 1. You should find that that is at the top of the second set of columns from page 534. And what it says is there's a Z of 1.00, and then you work your way across. Column B is for what's the proportion in the body. Is that what we want? Nope. Column C says what's the proportion in the tail. That's the one we want. So the proportion of scores in the tail located above a Z of 1, if we look at that and go over, we can see it's 0.1587. So what proportion of scores exists in a normal distribution above a Z of 1? 0.1587. Now, two things. First of all, we know that when we're doing calculations, we always round to the hundredths place. We always round what we're reporting. That's our calculations. Do not round the table. You'll find the tables change from table B1 to B2 to B3, how many decimal places they're written out to. This one's written out to 4, so guess what? We're using all 4. Do not round any of the tables ever. Leave them as they are. So, what proportion of scores is above a Z of 1? The proportion is 1587. Now, the second thing, notice the question asks, what's the proportion? That's all the table presents to you is proportions. But I could have asked, what percentage of the data exists above a Z of 1? Well, we learned how to convert proportions and percentages back and forth in Chapter 2. Take a proportion, multiply it by 100, and you turn it into a percentage. So if I asked you what proportion of the scores is above a Z of 1, the answer is 0.1587. If the question was what percentage of scores exists as Z of 1, then we would have to convert it. Multiplying it by 100 just means we're going to move that decimal place 2 spots. So it's going to be 0.87. So in other words, 15.87% of all the data is in the shaded area. So just almost 16% of it. So if the question asks for proportions, you provide proportions. If you were asked for percentages, you simply make that conversion. Now, let's do another one. What proportion of data in a normal distribution corresponds to a Z below negative 1.0. So what proportion of the normal distribution is below a Z of negative 1.0? Well, negative's over here on this side. Remember, proportions and percentages have to be positive. You can't bring me negative 4% of a pie, right? You can bring me none, but you can't bring me negative slice of pie. So proportions and percentages are always positives. Z's can be positive or negative. Remember, it's an address. Negative just says we're living on the left side of the curve or on the left side of the street. So again, I asked what proportion of the scores in a normal distribution corresponds to a below a z of -1. So below, I want to go this way, lower. So again, am I looking for body or tail? Once again, I'm in the tail. If I asked what proportion was above a z of -1, then I'd be on the other side, but I want to know what's below a z of -1. So it's the same strategy. You look in your tables and you look for a z of -1. Slide over to the proportions in the tail and you've got your answer. Are you finding a z of -1? No, you're not. There are no negative z's listed in the table. Why not? Remember that one of the defining features of a normal distribution is that it is roughly symmetrical. The left and right sides are essentially mirror images of each other. So they could have printed negative z values in here, but it would have been redundant. It's the same. The book doesn't know, the table doesn't know if you're on the left side or the right side, because it doesn't care. So we simply look at where the z of 1 is, and of course that means we're going to get the same answer. A z of 1, proportion of the tail, is 0.1587, or 15.87%. So the answer is the same. So I brought that question up to highlight the fact that if you're working on a problem that gives you a negative z score, the table doesn't know that. Just treat it like a positive one, because it's exactly the same on either side, the proportions. If I cut an apple in half, it doesn't matter if it's the left half of the apple or the right half of the apple, they're both 50%. So same thing going on here. Let's try another one. What proportion of the normal distribution is above a z of -0.50? Normal distribution, a z of -0.50, so that's going to be left of the center over here somewhere. And I said, what's above it? What proportion of the normal distribution exists above, corresponds to a z higher than -0.50? Now we're looking for the body. Now we've got the bigger piece. So again, we know that the z of -0.50 isn't going to exist in there, so we just look up 50. And in this case, we're going to look up, it's on the same page, 0.50. But in this case, we're going to look up the body side, not the tail side. So the proportion of the scores, the proportion of the data in that shaded section, if we go to a z of 0.50, so the very top of the same page, and move over just one column to body, we can see it's 0.6915. Or if we wanted to express it as a percentage, so it's kind of a safety check. Double check, what does your answer say? It says I've shaded in over half. Did you shade in over half? It's one of the ways to catch if you screwed up body and tail, if you've mixed them. You thought you were looking for body and you got a number smaller than 50. Well, that's the smaller piece. That's the tail, not the body, right? So that's some basic questions here. So we're going to continue on with some other sorts of questions. So let's say I want to know, using some of the data, some of the information we've learned in chapter 4 and 5 along with this, to get even a little bit more sophisticated questions put together. So let's put all those pieces together in the next clip.